Hello, I'm Junyoung. I'm going to present the paper Moebius, Metaprogramming using Contextual type, the stage where a system F can pattern match on itself, which is a collaborative work with Gélineau, Stefan Monnier, and Brigitte Pientka. Let's start with this question. What is metaprogramming? Metaprogramming is the art of generating, manipulating, and analyzing code. This technique is nearly universal. Compiler, user libraries, and program analyzers use this technique. For example, the standard library of Rust, Django framework of Python, and Metaprogramming project are a few concrete applications. However, metaprogramming systems have been suffered from one issue, a tension between their features and their type safeties. We introduced Moebius, a type-safe logic foundation which resolves the tension for the following metaprogramming features: the generation of system F-style polymorphic code, generation of code depending on code or type template, and pattern matching on code and type. Our theoretical foundation is based on the contextual modal type theory of Alexander Nanevsky, Frank Fanning, and Brigitte Pientka, and extends it with type variables and a new dimension called levels. We also show that the operational semantics of our foundation preserves types. In this talk, I'll demonstrate each problem we resolved in Moebius. First, the generation of polymorphic code. Here, we use the function nth that generates a code fragment to access nth element of a list V. The ceiling here means that it returns a code fragment. This prime a colon star is our extension, which allows the type variable prime a to appear in the result. The entire return type means that we should provide the list V and more importantly, the type prime a in order to execute or splice in the returned code fragment. When we use a code fragment, we first use letbox to make code X a variable in a future stage. Here, X stands for an open code template depending on the type variable prime A and the list V. Then, we instantiate X using with. If we call nth with an integer 10, it will return a code fragment that applies head to the list V after 10 applications of tails. Since this result allows us to choose the type prime A after the generation, this code fragment is polymorphic. Also, note that this result does not contain any extra redundant radices like a lambda abstraction immediately followed by an application, which is an advantage inherited from the contextual modal type theory. However, when you want to generate a code fragment that itself depends on another code fragment, we need to deal with another type of redundant radices, a box followed by a red box. Avoiding both of these radices is especially crucial if we want to allow pattern matching on code, because such extra radices may change the branch with which a code fragment matches. In Moebius, unlike the contextual modal type theory, we can also remove the second type of radices by introducing labels to distinguish a code template from a value. Lastly, the pattern matching on code fragment. When we pattern match on a code fragment, a pattern variable may depend on variable bound in the code. In this example, where P is a pattern variable, its type should tell us that it may access X. Likewise, if we use letbox in pattern, the type of Q should know that Q may access Y. Capturing the second type of dependency is not possible in the contextual modal type theory, and we can handle this again using levels. We pose our work to be a stepping stone towards multi-stage programming with dependent types. For more theoretical details, please visit my 20-minute talk. Thank you.